From the terrifyingly large colossal squid to the long-armed Japanese crab, the deep sea houses many such titans. These behemoths are evidence of something strange and curious going on in the depths of the water. For many years, scientists have been studying deep-sea gigantism, a perplexing phenomenon which has transcended from myth and manifested in the real world as something observable. This curious evolutionary trait has allowed the Japanese spider crab to grow limbs which reach over 13 feet in length. These crabs have a small body, but lengthy arms which are extremely adept at gathering food and fending off prey. The colossal squid is similarly affected, growing massive in size and weighing more than 1,000 pounds. It has eyes which are larger than basketballs, allowing the squid to see even the slightest of movements. A useful ability when darkness is your only companion. Large isopods, which are normally no bigger than a fraction of an inch long, turn into hard-shelled aliens the size of cats when it comes to the deep sea. From the larger species like squids and fishes to smaller ones like amphipods and crustaceans, deep-sea gigantism spares nothing. The life forms that we find deep within the water are mutated and transformed into something entirely unique. But is deep-sea gigantism really just an odd mutation or something more? The unique attributes found in sea creatures affected by deep-sea gigantism are not merely for show, but they serve a distinct purpose. In the depths, where sunlight is scarce and temperatures freezing, larger bodies hold more advantage. In order to precisely understand the root cause for deep-sea gigantism, we need to take a look at the harsh conditions in the deepest depths of the water. From the twilight zone all the way down to the hadal zone, things become extremely unfriendly. In these zones, the only constant is the darkness, a perpetual void which becomes more intense the deeper down we go. Over here, living organisms have to survive through expert adaptation. The freezing temperatures symbolize a world where time and life itself has slowed down. With no sunlight and biting cold, deep-sea gigantism becomes a necessity, which rewards a slower pace of life. In such freezing depths, a slower metabolism is rewarded, and larger life forms that survive without food for a longer period of time are the kings of the underworld. Since the temperatures never rise above 4 degrees Celsius, chemical reactions responsible for growth, reproduction and energy also slow down. This means that the larger bodies of a giant or colossal squid, for example, can sustain themselves without a constant need for hunting down food. Cold water also tends to hold more oxygen, creating another advantage for larger bodies. In tropical conditions, a larger body could mean death because it takes longer for life forms to absorb oxygen from the warm water. However, the cold waters of the darkest depths have oxygen in abundance, making it easier for sea creatures to thrive with such massive forms. This is precisely why deep-sea creatures such as the red-combed jellyfish or the vampire squid have also evolved to have a stark red colour, which allows them to absorb as much oxygen as possible. But this colour also appears completely dark in the depths of the water, thus serving as excellent camouflage as well. Apart from the cold, pressure also plays a key role in determining deep-sea gigantism. The pressure in the depths is not only intense, but also lethal. For surface-dwelling life forms, such high pressure is an instant death sentence. But for deep-sea giants, this harsh reality is just a simple part of life. Animals affected by deep-sea gigantism have a larger volume to surface area ratio, which means that their bodies are better suited to withstand such high amounts of pressure. They can swim in the depths without their cells distorting or their internal structures becoming unstable. This is precisely why something as monstrous as the colossal squid has a thicker, heavier form, which is hard to penetrate. In comparison, smaller creatures tend to survive better close to the surface where pressure is minimal because they hold a higher surface area to volume ratio. However, while factors such as the cold, oxygen and pressure can help us understand how deep-sea gigantism manifests in sea life forms, it does not explain everything. In order to dive into the crux of the matter, we also need to look at the eating habits of the creatures in the deep. When we think of the sea, we are often visualizing a colourful ecosystem where coral reefs and seaweed can be found everywhere, and there are countless small creatures swimming about. But this reality only exists for the upper regions. In the lower depths, things start to look apocalyptic and barren. Since there is no light deep underwater, photosynthesis cannot take place. This results in an empty vacuum where life seems altogether missing. However, this lack of life is only an illusion, because even in the depths, activity is rampant. Take marine snow, for example. This snow is actually a slow drifting life shower made up of dead plankton and organic matter that falls to the bottom of the sea. Even though most of the marine snow is eaten up before it can satisfy deep sea creatures, it can still sustain life for a long time. The vampire squid is especially built to expertly catch as much marine snow as possible with its web-shaped tentacles. On rare occasions, the deep sea also gets to experience the fall of a decently sized fish or whale carcass. Such events feed entire communities for several years. These unique eating habits reflect just how crucial slow eating is and why deep-sea gigantism reigns supreme. Larger bodies release energy slowly and take a longer time to metabolize food. This means that for deep-sea life forms, size can be the difference between life and death. Large, deep-sea isopods that are as big as puppies can survive without food for long periods of time, thanks to their energy reserve and slow metabolism. Similarly, the Greenland shark is known to take several hundred years to reach maturity. In fact, this remarkable shark can live for 400 years, going through countless decades and centuries in an unchanging and unwavering manner. Most deep-sea creatures quietly play the waiting game, taking decades to change slowly but surely. Even though deep-sea gigantism truly creates some of the most impressive sea creatures in terms of size, this fascinating phenomenon is extremely multifaceted. From metabolism to growth and reproduction, deep-sea gigantism makes sure that life is a possibility no matter what. This also means that sea creatures affected by gigantism are also apex predators in their own strange ways. Take the big red jellyfish, for example. Its large size is a defensive and offensive mechanism which keeps the jellyfish safe from being eaten by anything else. Similarly, the colossal squid is known to be incredibly aggressive. It has sharp hooks on its tentacles which allow the predator to viciously latch onto its prey. Colossal squids are also known to battle whales in the deep waters, making this behemoth even more terrifying. Since there are no hiding places to be found in the abyss of the water, having a smaller body and fast movements is pointless. Instead, sea creatures use their gigantism to dominate the underworld. Their movements are deliberate and slow instead of fast and instinctive. With nowhere to hide, animals have adapted to dispose of the need to hide altogether. Thus, another reason why the deep sea favours gigantism. However, deep sea gigantism should not be seen as some sort of a mutation that inflicts life forms deep underwater. When it comes to the deepest, darkest depths of the seas and the oceans, we are talking about a space forgotten by time. Over here, evolution is slow, and most species have barely changed over the years. This is precisely why deep-sea creatures are also referred to as living fossils. They exist in an entirely different region, one that is untouched by the fast motions of life. In light of this, deep-sea gigantism is merely a way for this stable region to remain consistent and to preserve itself as much as possible. This is why sea creatures here have adapted an ecological strategy known as K-selection. This strategy allows animals to produce fewer but larger eggs, leading to larger lifespans and a stable population. The giant grenadier fish is known to follow this strategy compared to its surface-dwelling counterpart. Unlike the upper regions where life is always competing, where species must take part in a fast-paced race of survival, the abyss remains still. In the vastness of the water, life itself begins to experiment with different possibilities. Some creatures, like the anglerfish or the dragonfish, have their own unique methods of coping with the darkness. They produce their own light to lure in enemies. On the other hand, we have species like the colossal squid or large isopods, who have broken through the limitations of evolution. Deep-sea gigantism is merely the result of life being allowed to grow and thrive. It is odd to think of such a dead region brimming with life, but this is precisely what deep-sea gigantism serves to remind us. That life is not a singular event, but a series of possibilities rushing to survive at all costs. In the past, this stubbornness was mistaken for sea monsters and krakens, but now we know that those monsters of old were simply the wonders of the deep sea.